Hello to everyone watching this. This is question number 2 on November 2022. Question paper. This is question number 2. We are going to answer the questions on this question. Let's start by analyzing the statement that we have crate P of mass 1,25 kg is connected to another crate which is Q that has the mass which is 2 kg. The crates are on the rough horizontal surface. A constant force of 7,5 Newton act on an angle theta to the horizontal. The crates accelerate at 0,1 meters per square second to the right. Okay. Then we are given the diagram here. Crate P experiences a constant frictional force of 1,8 newtons, whereas Q experiences a frictional force of 2,2 newtons. Now the first question that we are going to do is the question that says draw the free body diagram for Q or for P, but we are going to draw the free body diagram for both crates. So let's start. The first thing that you need to do when you draw the free body diagram is to draw the force diagram. So let's draw the force diagram. We have the vertical force, the perpendicular force that is exerted by the surface on an object in contact with it, and it must be always, and it acts so we have the frictional force here, that is Fk. Then we have Fg, which is always going down. Then we have this force that pulls Q, which is or P, that is tension. Then this tension also pulls Q, same tension. And then we have the friction on Q. There's a friction on Q. Then we have the normal force which acts perpendicular to the surface, and then we have Fg here. Then we have this force that is applied. Now let's draw the free body diagram. For P, which is 1,25 kg, the free body diagram will be like this. We just remove the object there. We put a bullet, so we have the normal force. Then we have Fg. We have tension. Then we have friction. Then for Q, also Q, which is 2 kgs. For Q, we have this free body diagram. We have the normal force, that is normal force. Then we have Fg. Then we have the force that is at an angle, force that is applied at an angle. Then we have Fk as well as the tension. So if we are talking about the marks, we have 4 marks here because there are 4 forces, 4 marks. Then here we have 1, 2, 3, 4, 5, which means this one would be 5 marks. Okay. Another thing that is very important is to know that when you see the slanted force, you must draw the components. So we have the Fx component, then we have Fy component. Then you must remove the original. After we've written the components. Then the second question after the free body diagram was saying calculate the tension. That was the first question. Then the second question, calculate the tension. Calculate the tension in the string, and it was 4 marks. So this one is very easy when you have already your free body diagram. Now if we can look here, we have the friction. Here the friction is given. Here is the friction, that is 1,8 newtons. We also have the friction here. The friction here is 2,2 newtons. Then the force F is equal to 7,5 newtons. Now let's answer the question which says calculate the tension. Now when you calculate the tension, you must look at your data. On object P, we have tension that is involved that we are looking for and Fg. Since tension is a horizontal force, we are going to deal with the horizontal forces. Then since tension here is also a horizontal force, we are going to deal with horizontal forces. Then here we have only two forces, tension and a friction, and the unknown is only a tension. But here we have a tension Fx and a friction. We have two unknowns in this side, meaning that we must start with P to get the tension. So Fnet is equal to MA. So Fnet is the same as, if we look at this object, is the same as this one is going to the right, must be positive, then this one must be negative. Therefore tension must be positive, but Fk must be negative. Okay, now we can substitute. We are looking for a tension, but the friction is 1,8. Then the mass of this object is 1,25. So the mass is 1,25. Whereas the acceleration is given in the statement, that is 0,1. So the acceleration is 0,1. Then we transpose this one, then we get the tension, which is equal to, then the tension is equal to, when you transpose this one, this will become positive this side, so we'll have plus 1,8 plus 1,8. This is 0 because it is transposed. Then we get 1,925 newtons. That is the tension. The following question says calculate the magnitude of the angle theta. Now where is angle theta? The angle theta is on Q object. We have angle theta here. Fx is equal to F cos theta. We are looking for this theta, which means we must first get Fx so that we get the theta. Now we will use the same formula. Fnet is equal to MA. So this one must be positive, these two must be negative. So we have Fx minus Fk minus tension, which is equal to MA. Now Fx is what we're looking for now. Then the friction for this one is 2,2. It's 2,2 minus the tension is calculated in this question, which is 1,925, which is equal to the mass of this object is 2 times the acceleration of the system is 0,1. Then we solve for Fx first. We are going to calculate, press calculator here, then we transpose, then we get Fx. Then we get Fx, which is 4,32. Then Fx is equal to F cos theta. We're looking for theta. This one is 4,325, which is equal to, the force is 7,5 cos theta. Then we divide by 7,5 both sides, 7,5. Then we get cos theta, which is equal to divide by 7,5, then we get 0,058. Then cos theta, therefore theta is the same as cos inverse of 0,58. Then theta is equal to 54,78 degrees. That's it. Then we are done with that question. Thank you very much. Please subscribe to my channel. Please share the video. Please download, comment, add, correct where there is a mistake. You can ask questions. You can also join me on Facebook, Lukhona M Sciences. You post the questions there. I'm going to help you. Thank you.